Okay, everybody, I have student named Michaela, fake Michaela, sitting beside me, and she's going to be my helper today. So, fake Michaela, can you please tell me what's the square root of 36? That's it. All right, now what about the negative square root of 64? It's okay if you get it wrong, nobody knows who you are. That's perfect. What about the cube root of 128? Uh-oh, I have an old calculator. I don't know if it's on there. It is! There's number 4 in your calculator. 128. Oh, that's unfortunate. So the bad news is that this is a decimal, so Michaela, we can't use that. That's icky. Here it is. That's icky. Can't use it. So then we would go to our list, which I conveniently misplaced. Can you think of any perfect cubes that go into 128? 64 is correct. 64 is a perfect cube. Times, do you know what 64 times? Yes, 64 times 2 makes 128. Do you know what the cube root of 64 is? Good. So that becomes a 4 with a cube root of 2. It's like she's a freaking genius. Oh, can I say that? Okay. Okay. I don't tell my boss I said that word. Okay, now let's do I really might edit that out. Okay, let's do 800. Do you know what perfect square goes into 800? That's perfect times. Oh, hold on. We can do better than that. Not just 100, folks. Bigger perfect square would be. That's right, we're going to change that 1 into a 400 times 2. 400 times 2. The square root of 400 is. Square roots of 2 left over. Very good. Now, number 5. Michaela, can you guess what we're going to do to these two things? Say. Yes, very good. So 30 times 6 makes 180. And do you know what perfect square goes into 180? Because I don't. I feel like it might be 36. Oh, it's an icky decimal. Okay, so do 180 divided by 36. I think we're going to get 5. Try 36, not just 6. Yay! Where was I? So that's going to be 36 and 5. What's the square root of 36? Very good. And then the square root of 5 is left over. Now, number 6, we have an issue because we're not allowed to have square roots on the bottom. So the first thing we're going to do is see if these divide. What's 35 divided by 5? Very good. So that ends up being the square root of 7. There's no perfect square inside of 7, so that one's done as is. Very good. All right, now number 7. Does 7 divide by 5 evenly? No, it doesn't. So we have to get rid of this 5 by multiplying by the square root of 5 on top and on bottom. All right, Michaela, what's 7 times 5? So the top becomes the square root of 35. What's 5 times 5? So the bottom becomes the square root of 25. Now, is there any perfect square inside of 35? No, there is not. Very good. So we leave it the square root of 35. Is 25 a perfect square? Yes, it is. What's the square root of 25? Very good. And then that's the end of it. We got rid of the radical on the bottom, which was the goal. Number 8. What's the negative square root of 36? Very good. And that one's done. Now, number 9, whatever you do, don't add those together because if this is multiple choice on the test, I promise I have that wrong answer on there. Instead, try to tell me what perfect square is inside of 56. I think we're look. Is it a decimal? So that stinks. So we can't change that to anything perfect. Try dividing by 4. What's 56 divided by 4? Perfect. So 56 is 4 times 14. Oh boy, 126 divided by, I don't know. Let's try 36. Oh, that's a decimal. Let's do 126 divided by 4. Oh, this isn't good. What's 126 divided by 14? Let's see if we can get to my. Ah! So it's 9 times 14. I knew something would match. Okay, so what is the square root of 4? So this becomes a 2 square roots of 14 plus what's the square root of 9? So this becomes a 3 square roots of 14. And then do these match? Yes, what's 2 plus 3? So we get 5 square roots of 14. So on the test, please be sure not to just add the insides together. That's a big no-no. Ooh, what do we notice about these roots here? That's right. So we can just do 8 minus 3 is good. So you have 5 cube roots of 7. End of story. Good job. Number 11. Let's try 24 in our calculator. If we get an ugly decimal, we have to do that thing. Ugly decimal? Ew. What goes into 24? Times? Very good. So 4 times 6, it makes 24. What's the square root of 4? So we have 2 square roots of 6. We're doing great. We can not finish in 2 minutes, but that's okay. I'll just finish the video later. Okay, number 12. Oh, we're going to do it again. Do you know what perfect squares in 200? Think big, like this, maybe that. So it's an icky decimal. Yeah, so 100 times. Good. Ooh, there's a negative inside the square root. Do you remember what? No. I. Yes, I'm gonna to steal Mrs. Miles' joke. She'll say, "Pull your eyes out, but don't go blind." Okay. So the square root of 100 is 10. I almost called you by your real name, Michaela. The negative becomes an I, and the square root of 2 is left over. Bridget over there wishes she was participating too. Okay. Now this plus 3. Do you know, Michaela, what goes into 8? What perfect square goes into 8? Yeah, you did. So here's the 3 from the original, and then we have 4 times 2 to make 8. Well, what's the square root of 4? Yeah, so this is really like 3 times 2 square roots of 2. Oh, P.S., there's a negative, so this is really going to be a what right here? Or, yes. So 3 times 2 makes, yep. So this is a 6i. I have a feeling some kids don't know where this 2 came from, so we should probably review that one more time. It was 8 was 4 times 2. The square root of 4 was 2. So 3 times 2 is 6. So 10 plus 6 is? That's right. That, folks, is the end of our story. We'll pick up later. Thank you, Michaela. The next problem on number 13, you're going to find what perfect square goes into 108. I believe the answer is 36. Okay, so you write 36 times 3, and then the perfect square that goes into 12 is 4 and 3. Now these are negative, so these are going to need i's. So the square root of 36 is 6, but because it was negative, we need an I with a square root of 3 left over. Then we drop down the outside minus 4. The square root of this 4 is a 2, so we write times 2 with an I because it was negative. Square root of 3. This is 6i square roots of 3 minus 4 times 2 is 8i square roots of 3. Then you combine your like terms for negative 2i square roots of 3. Number 14, you distribute. So you do square root of 3 times square root of 3 is square root of 9. Square root of 3 times negative 8 is negative 8 with the square root of 3. Then the insides are positive 8 with a square root of 3, and then the outsides are negative 64. Then you simplify what you can simplify. So the square root of 9 is a clean cut 3, and these join and they actually cancel each other. So we have 3 minus 64 for a total of negative 61 as an answer. Okay, at number 15, we're going to do square root of 6 times square root of 7 to get the square root of 42. Then we'll do the square root of 6 times 4 to get positive 4 square roots of 6. Then down here to get negative 5 square roots of 7. Then up here to get negative 20. Then there's actually nothing that goes into 42. It's kind of surprising, but 42 does not reduce. The square root of 6 doesn't reduce, and the square root of 7 doesn't reduce. And we can't put any of them together because they don't match, so that one's all done. Number 16, you're going to do 3 times 2 is 6. 3 times negative 3i is negative 9i. 4i times 2 is positive 8i. And 4i times negative 3i is negative 12i squared. We're going to keep the 6, but we're going to put those and combine them to get negative 1i. And then we learned in chapter 4 that negative 12i squared simply becomes a positive 12. And we lose the I squared. 6 plus 12 is 18, and the minus 1i drops down behind it. Number 17, we're going to do 2 times 2i and get 4i. Then we'll do 2i times 3i and get positive 6i squared. Then we'll do negative 3i times 2 and get negative 6i. And we'll do negative 3i times positive 3i to get negative 9i squared. We're going to keep, I guess we can put our 4i with our minus 6i together to get minus 2i. And then we learned from chapter 4 that this plus 6i squared just becomes a minus 6. We lose the I squared. And then this minus 9i squared just becomes a plus 9. So when we combine our like terms, we get a 3 from our real answer, from our real constants here, minus 2i in the back. Number 18, we are going to multiply to get rid of the I in the bottom by 7 minus I over 7 minus I. The conjugate is what that's called. Multiply the top. 4 times 7 is 28. 4 times negative I is minus 4i. On the bottom, you do 7 times 7 is 49. 7 times negative I is minus 7i. I times 7 is positive 7i. And I times negative I is negative I squared. The top doesn't simplify at all. We have to leave it as 28 minus 4i. There were no I squareds to deal with. And the bottom is really 49. Those terms cancel out. And we learn from chapter 4 that negative I squared is just a plus 1. So 49 plus 1 is 50. That's a really good answer, except everything divides by 2. So when we divide by 2, we're going to 14 minus 2i over 25. Final answer. When we approach number 19, we're going to do the same thing that we did in 18. It's just going to be a little bit more involved with the numerator. We'll multiply by 3 plus I on the top and 3 plus I on the bottom. The next thing we do is redistribute. 5 times 3 is 15. 5 times I is 5i. I times 3 is 3i, positive, and I times I is I squared. For lack of a better term, or for lack of a real math term, we're foiling, although FOIL is not a real math term. So 3 times 3 is 9. 3 times I is 3i. I times negative I times 3 is minus 3i, and negative I times I is negative I squared. Let's deal with the top for a second. So these two are going to join to be 8i because they're like terms. And we learned in chapter 4 that a positive I squared is just a negative 1. So we have 15 with a negative 1. So behind the 8i, we're going to have a positive 14. On the bottom, the 3i's are going to cancel. And this is going to become a positive 1 we learned in chapter 4. So we have 9 plus 1 is 10. And just like the last problem, we divide everything by 2. 4i plus 7 over 5. Final answer. All right, in number 20, I included this one because I think sometimes it's a big missed item on the final. It was on review number 1 as well. Subtract 3 from both sides. So we get the square root of 3x minus 3 equals x minus 1 when we kind of subtract and combine. Oh, that is a very bright light. There we go. Now you're going to square both sides. Now when you square the left side, it's going to be pretty easy. It's just going to turn into 3x minus 3. When you square the right side, you do have to write it twice and distribute. So you get equals x squared minus 1x minus 1x plus 1 when you distribute, or again, FOIL if that's the word that you want to use. So we minus 3x on this side, add 3 on this side. Oh, you know what? Let's combine our like terms instead. So we're going to have 3x minus 3 equals 1x squared minus 2x plus 1 when we combine our like terms. Now we'll set it equal to 0. So minus 3x and add 3. Minus 3x and add 3. So we get 0 equals x squared, or 1x squared, minus 5x plus 4. Pause the video if you need to figure out where each step came from, if I'm going too fast. Then we do the quadratic formula. So we do negative b plus or minus the square root of b squared minus 4ac all over 2a. And you guys can hopefully hear how much the quadratic formula is going to be of use on the final. So that's 5 plus or minus the square root of 9 over 2, which turns into 5 plus or minus 3 over 2, and 5 plus 3 is 8 over 2, and 5 minus 3 is 2 over 2. So final answers of 4 and 1. You should, however, check both of those answers in to make sure that they are correct. I'll start by checking in positive 1. So if I check in positive 1, I get 3 minus 3 is 0. Square root of 0 plus 3 is 3. So 1 does check in. Let's check in 4. So that would be 12 minus 3 is 9. So the square root of 9 is 3 plus 3 is 6. And then 4 plus 2. So they actually both check back in. You can give them both a little check mark. The next problem is just like it's going to be on the final. There's 1, 2, 3, 4, 5 parts to it. That's 10 points on the final. So right here, this simple quadratic problem, it's going to be they're asking you to graph a parabola. is 10% of your whole final. And I know you guys are really good at this, okay? I think you need to ask her. I think you're on my video right now. Yeah, just, I wouldn't ask her, no. I wouldn't. You're still on my video. I'm not even going to edit this out. Okay, say hi. Say it real loud. There you go, thanks. All right, you people who don't listen to the sound are just wondering why I'm not doing anything right now. All right. Find the x value of the vertex. I think it's funny. So that's x equals negative b over 2a. Please remember that when you come to your final. For negative b, you're going to do negative 6 over 2a is 2 times 1. So it's negative 6 over 2, which is negative 3. So when it says find the x value of your vertex, that's going to go right here in the middle. It says, what is the point of the vertex? You can plug negative 3 in by hand. There's certainly nothing wrong with that. Or you can use your calculator. There's also, in my opinion, nothing wrong with that. So we're going to have x squared plus 6x plus 7. And we can plug in negative 3. And you'll get negative 2. I mean, you can plug that in by hand. There's certainly nothing wrong with actually doing math. So find the point in the vertex. We're going to write negative 3 comma negative 2. Next, does it open up or down? Well, since it's a positive in the front, that means it's going to open up. But if you're not sure, just hit graph and you will see your parabola opening up. Next, does it have a min or a max? Well, since it opens up, it's going to have a minimum. Again, if you're not sure, look at your graph. You can see it has a bottom to it. Sketch the graph. So I'm going to need to plug in more numbers that surround negative 3. And then I'm going to plug those in. You can plug them in by hand. You're obviously more than welcome to do actual math. Or you can use your calculator if you want. And when we plot the points, we're going to get, so here we go on the final. That's 10 points right there. 1, 2, 3, 1, 2. There's your vertex. Here we go. Look how pretty that is. And there you go. You just earned yourself 10 points on the final. Last thing, Christy has 12 shirts, 4 pair of pants, and 13 pairs of shoes. How many different outfits does she have? Those are all different things being put together, so you multiply her different options together. Don't overthink this problem. I have a student trying to leave my room right now. Don't leave. 624 outfits. Really, I promise it's on the final, and it's that easy. Have a good day, folks.